Welcome to this video on variation part 2, direct and inverse variation. Let's begin. Example 5, write an equation to symbolize the relationships in the table below. Y varies directly as x. So in the last video, we learned that this is y is equal to kx. Now, however, we're introducing a different word, which is inversely. So how do I express the idea that y varies inversely as x? Well, that means that x has to go in the denominator. So we have y is equal to k, not k times x, but this time we have k divided by x. Okay, now this one says y varies inversely, so I know that our variable is going to go on the bottom. But the variable isn't just x, right? It varies inversely as the square of x. So I need to write x squared there. Okay, now we have the word jointly. Jointly is very similar to directly. The only difference is that we have not one, but two variables. Okay, so y varies jointly with x and z means that it varies directly with x, and it also varies directly with z. So both x and z need to go upstairs. Okay, what if I said y varies directly with x, so I could write y equals kx, and then inversely with z, so then I'd have to put z downstairs. So let's apply some of these in some more practice problems. Example 6 says j varies inversely as n. When j equals 95, n equals 15. Find the constant of variation k, and then use this information to construct an equation to represent this relationship. Then find j when n equals 5. Alright, let's just break this down one piece at a time. So the first part says j varies, so we write j equals inversely as n. So that variable n has to go downstairs. Okay? Then it says when j is equal to 95, then n is equal to, let me write this better, then n is equal to 15. Okay? So we need to multiply both sides by 15. So what is 15 times 95? Well, it's kind of a large number. It is 1,425. So that is our value of k. So we can go ahead and write that answer down in the very first blank. So we can say that k equals 1425. Okay, so now we can write our equation. How do we do that? Well, our original equation was j is equal to k over n. But we just found k, didn't we? We found that k was 1425. So our equation is now going to be j is equal to 1425 over n. So now we can write that in place of our equation. J equals 1425 over n. Alright, so we've done what they asked about writing the equation. Now I can do the last step, which is to find j when n equals 5. So we have j equals 1425 divided by n, but n is 5. So if you type this in a calculator, you get j is equal to 285. So that will be our answer. Okay, let's do a few more examples. Example 7 says we know that b varies inversely as the square of a. So let's just stop there. So whatever the first letter is that goes on the left-hand side, we write b, varies, that means equals. Okay, then we always write our constant of variation upstairs. Okay, it varies inversely, so we know that our variable is going to go downstairs, but it's the square of a, so it's k over a squared. Okay, so I've taken all of the information in that first part and I've used it. So the second bit of information I need to use is that when b is 9, then a is 3. Okay, so I have 9 is equal to k over 9. How do we solve this? Well, we just multiply both sides by 9, don't we? So then our constant of variation is 9 times 9, which is 81. So now we can use this value to rewrite our equation. So instead of writing b equals k over a squared, I can say that b is equal to 81 over a squared. So that's my equation, b equals 81 over a squared. So last but not least, I can find b when a equals 5. So I'm going to say that b is equal to 81 over, let's build a little nest for our variable, right? So that's for a, and a, it says, is 5. So it's going to be 81 over 25. And remember, we're totally fine with improper fractions. You can try to factor it, but it doesn't factor. 81, the only thing that goes into that is like 3s and 9s and stuff. And the only thing that goes in 25 is 5, right? So they don't have any, there's nothing you can cancel out. So 81 over 25 is the reduced value. All right, so let's do one more example here. So example 8 says z varies jointly with x and y. So how can we write that? So remember, jointly is direct variation. The only difference is that it's joining, as it were, multiple variables. So we have z is equal to kx because it varies directly with x. It also varies directly with y. Okay, so we have z equals k times x times y. Then we're told that when y equals 2 and x equals negative 3, then z is equal to 12. So we can use that piece of information to find k, our constant of variation. So we have 12 equals negative 6k. So we just divide both sides by negative 6, and we find out that k is negative 2. So now we need to take this piece of information to write a more complete equation. So instead of saying z is equal to kxy, I'm going to say z is equal to negative 2xy. So that's my equation. Z is equal to negative 2xy. Okay? So then lastly but not leastly, we use that equation and we plug in x is 5 and y equals negative 1. So again, we have z equals negative 2xy. We want to find z when x is equal to 5 and y is equal to negative 1. So that turns out to be positive 10. You can check in your calculator that that is correct. And that's it. That is the answer to that question.